Alright, Jake, you are getting to watch this recording thanks to Matt. So if you'll give Matt some kudos, also known as Big Tony. Alright, so what I just discussed when Matt stopped me and said you need to record for Jake was that on number 37 right here, hopefully you noticed that you got -3 as an answer. But if we plugged in -3, we have log base 10 of -3, which is not possible. So -3 is not a valid solution. So we call it a
extraneous solution.
Extraneous solution. It's an answer we got that doesn't work.
Extra wrong.
It's extra wrong. Yes, it is. Okay. So the slides for all the answers will be on the website also, so you can link to that. But guys, do you have any questions other than the ones you can see? There's 32, 33, and 37 all worked out. Did you see on 33 you got plus or minus 20, but you can only do the positive 20.
Okay.
No?
Yeah,
You didn't get plus or minus 20?
No, because I was so
Oh, no.
What page was this on?
Because you have to swear it.
I'm not glad. I was very, very confused on number 33 is kind of out of my head. Can you do number 22 or 23?
22. All right, so 22 is right here. This is how we started this unit with exponents. So can we write these with the same base? Sure. 1/4 is to the -2nd. 8 is to the 3rd. So we distribute the -2 and distribute the 3. Well, we didn't have to distribute the -2, just multiply. I'll move the -2x over here, the -3 over there, so we get 3 equals 5x and divide by 5.
That was so easy. I couldn't figure out how to make a common base because I forgot about negative exponents.
Gotcha.
So I tried to plug in a bunch of stuff.
Okay. But you remember now?
Yeah.
Awesome. All right. Any other questions? Yes, Sid.
I think I said it wrong. Never mind.
Okay. Anybody think they have a question that Jake may have had? All right, John?
For a 22, it's the negative 2x
Because it's a fraction.
That's a Jake question.
All right. There you go, Jake. That was for you. All right. Any other questions?
Can you scroll back up to 33?
Scrolling back up to 33.
Thank you.
Oh, there it is. I moved both logs to one side so I could combine them.
Yeah, I got that.
And when you combine x divided by 12 times 3x, you get 3x squared over 12. And 3 goes into 12 4 times. X squared over 4.
Factor on number 37?
I sure did.
That's why.
It was a quadratic, and factoring is always my favorite way to try.
Yeah, that's what I did.
So I always try factoring first, because for me it's the easiest.
Regular math is just now solving quadratics.
Meanwhile, we're learning this.
Yeah.
Good.
Hashtag learn.
Good for them.
Learned.
Hashtag learn.
I say congratulations.
Yep, we're working
Hashtag
on
learn, Pierce.
regular 11th grade classes right now.
Really? So we're like a year.
We are actually doing the
They're like
exact
2
same
years.
thing that the 11th grade course is doing right now. They just are getting to logs, but they don't, unfortunately, get to do some of the cool stuff that we do.
So we're like a year ahead of like the freshmen in this class. We're like 2 years ahead. That's
Aren't you guys lucky?
We
It's weird because this stuff isn't like that hard to get.
That's a stretch.
All right. Sid, is yours just a question about philosophy, or you got a math question? You had your hand raised, and then it came down, and then it went up. Now, all right.
Yeah.
Okay. I bet I don't even have to teach this. Yesterday, we just did properties with logs. Today, we're still doing properties with logs, aren't they? They're just special logs.
the ln.
It's log base e, which makes it a natural log, right? So, we treat it the same way. It's the same thing. It just has a different base. Yesterday, we did base 10. Today, we're doing base e. Yes, Mateus.
If it's a natural log, you don't have to write
Well, this actually is natural log of e to a number. So I kind of already spilled the beans over here and told you what natural log of E is. But natural log is really, when we think about it, log base E of E. And what power do you raise E to get E? 1. So whenever we see natural log of E, we know it has a value of 1. So if we had a problem such as this, natural log of E to the 4th, it becomes 4 times natural log of E. And we know that natural log of E is 1, and 4 times 1 is 4.
We have a test on that only. Well, maybe you should.
That will be on your quiz Wednesday. Quiz Wednesday, Jake.
Quiz Wednesday, Jake.
All right. If you look at your calendar, we have review on Monday and Tuesday. So today's the last day of new material. I did post the review to the website, a PDF version of the review to the website for those of you that like to work ahead or might meet with a tutor this weekend, or I don't know. But Monday will be a work day, and Tuesday will be a go over it day. It's a nice packet of work, though. It's a. You know how y'all like to be fully prepared? You will be fully prepared.
Oh, well,
All right.
there's too much and you can't learn all of it. So it's like,
You already know,
Every day.
Caroline. You're just practicing.
All right, natural log of E to the x minus y. What do you think we do?
multiply x times y out.
That x minus y, we rewrite from the exponent into a product. And natural log of E is just 1, so my answer is x minus y.
But can that be like? Oh, well, I guess it can be an answer.
What's the answer to 3?
Negative 2x.
Negative 2x.
Well, I like this.
That's
So
easy.
what-
You're a genius, buddy.
So whatever the,
Everything
whatever
just
the power
made-
is, you know.
The x.
Okay, but do you understand why?
No,
Yeah.
not really.
Yeah.
Yes.
Okay, you don't understand the why. All right, do you remember that? Wow. The book just fell off the cart onto the ground, Jake. All
Everyone panic.
right.
He's actually gonna watch it.
Jake, you don't die. Like,
If he doesn't watch, it's gonna die.
All right.
I bet we should explain what
I have to
happened.
ask him how many times you say his name.
That's a good idea.
Jake, a book just fell.
Okay. So
Calm down, Jake. Don't panic.
when we studied our properties of logs, we said that when we had log of this, that it's the same as b times log of a. And we talked about why. Because the answer to a logarithm is an exponent, right? And when we raise a power to a power, what did we do with those exponents?
Multiply.
We multiplied them. That's why this is true. So whenever we have any of these, this can come out in front. Does that part make sense?
Yeah.
Okay. Now, so the part that's struggling is right here. The fact that the natural log of e is actually 1. Well, natural log just means log base e. And so if we set that equal to an exponent and we switch forms, e to the x equals e. Well, this is an understood what power? 1. So x would have to equal 1. This simplifies to 1. So whenever you see natural log of e, we know it has a value of 1 because it's asking us what power do we raise e to get e. The answer to a logarithm is the exponent, and we raise e to the first power to get e. So ln of e is just 1. All right, this one's a little different, but it's not hard. What do you think the answer is before
2.
we start? You're right. The answer is 2, but now let's figure out why.
Oh, because it's e to the
Okay,
e times
let's just equal some variable,
Then switch
and let's switch forms. So the natural log, we're switching forms. Well, let's just log base e of the answer equals the exponent. But like I just said a second ago, do we ever write log base e? No. Instead of log base e, we write natural log. So what is the only way this can be true? Is if y equals 2. So the answer is 2.
What if the natural log wasn't there at the top part?
If the natural log wasn't there and it was just e squared,
Then then
it's just e squared. It's just that number e. What's the approximation for e? 2.718. Good. It's 2.718 squared. but not exactly 2.718. We know it keeps going forever. It's an irrational number. Yes, Sid?
How did you get ln times y? I don't understand where that came from.
I switched forms. This is an exponential form, and I switched to logarithmic, so it becomes log base e of the answer equals the exponent.
Okay.
Then I said, oh, we don't write log base e. We write natural log.
Okay.
So y has to equal 2. So 2 is the answer. What's the answer for number 5?
Why?
Y. What's the answer for number 6?
3 ln.
6.
Okay, we've got several 6s.
It's not 6.
2.
Got a 2.
What do you think, Jake?
Good job, Ryan.
Jake, think about what you would choose as your answer.
Jake, go with John. He's the bum.
Let's give him a second.
Whoa, Mercedes, you don't have to compliment me like that.
3. Good job, Ryan.
1.
Okay, so the 3 is not like these, is it?
I'm gonna join the rest of the crowd. I switched my answer to 6.
We have a lot of 6s.
Starter.
The reason I haven't kept going is because I haven't heard the correct answer.
1, 2, 3,
Oh.
4,
Why?
5,
It's
6,
why.
7, 8.
The answer's
2
why.
thirds or 3 halves? Am I close?
Oh, wait, what?
No, 2 thirds. 3 halves.
I said that.
Oh.
I said 3 halves.
3 halves.
Okay,
Top Pierce.
That was hilarious.
is this the same as this?
I got it.
No.
Sure.
Yes.
8.
Yes. 8.
So it's 8.
Oh, John was.
I've been washing my hands.
Wait, how was that?
Okay.
She was like,
Then we're still.
I got just enough.
Wait, is the L in?
wait, what?
No, I said it's a
Wait, I
Y.
didn't write this down. You put.
Oh my god.
Okay. I guess one of those things.
Matthew got that one first try. Matthew Hargrove, 3rd period. Didn't even take a second.
No, that's genius.
Why would the 3 be out front of the E? Because wouldn't it be
Can't-
3 times E?
Well,
I.
if we can take them out in front and write them on multiplication, can't we go the other direction also?
Yeah.
Yes. Okay. Alright, I'm not even going to tell you what to do because this is just like yesterday.
Oh, man.
We're just using a different base. So you try this one.
Oh baby, let's go.
You take my pencil.
No, I took Will's pencil earlier. Though. You saw me.
Yeah, no, I'm not.
Pierce, the album cost parks outside today.
Yeah, but. Yeah.
Why'd you go outside yesterday?
I went outside yesterday. Em went outside yesterday.
I was first side.
Never mind. Em had.
That's a square.
That's just like pain that happens to be
Yeah, the album ice practice.
We haven't. Okay,
That can be specific.
The 2x4
This will be
square
doing
7.
equations like this. You basically keep the letter E or just like leave.
Oh, it would be 8.
8 squares.
Even if you
8
multiply
squares.
it, it's like-
Boxes.
If unless I ask you for an approximate answer, you would have to leave E in your answer here.
Let's go. Go with that.
Yeah.
Oh.
Because you said area.
how do you?
Perimeter.
Can you have a number E? Like, can you have 5E?
Yeah. We just talked about this. Yes. Yes, you can.
Did you get 5/8Z?
Yes.
Yeah, but wait.
Would have to eat.
Would it?
Yeah, we got.
Would it be the same thing? Would it mean the same thing if you put 5e over 8?
That's what I did.
Sid, can you answer that question yourself?
I'm not sure.
That's a good answer.
So, Sid, do you know, is
It was the
this
same.
equivalent to this?
Yeah.
Okay.
Just making sure.
Alright, so Sid wants me to write it like this and he'll be happier.
Sure.
Alright,
Sorry.
there we go.
Oh my god.
I'm good with that. I'm good with that. Alright, so, oh.
I can.
Alright, you can do it?
Yeah.
Fabulous.
Well, I'm gonna try.
All right. What? Who knows what power I raised 2 to get 5?
I don't know.
Some decimal.
Yeah.
2.3.
5/4.
It's 2
I'm gonna go with 2.4.
2 point.
Okay, we got two.
Oh, it's
2 point lots of things.
Well, you could you
Five.
could put it to a similar base.
2.3.
Oh, it's 2.5.
It's oh wait.
And 1/3. 2 1/3, definitely.
I give
2 1/3, definitely.
2 1/3.
All right.
Wait.
All right. Those of you that are really confident in your answers, take out your calculator and raise 2 to that power and see if you get exactly
You can't.
5.
I don't
All right.
I
So these
I-
can't-
One of
wait,
those things where
wait.
we spend like
You have to set 5 to
five.
Not exact.
It's like
I'm kind of confused now.
We're just thinking right now. I haven't told you hardly anything to be confused.
I got it.
Let me get a calc.
I gotta try it.
So this is this your paper? That's all.
What about students?
Told you it's 4M.
All right. So none of you are right. None of you had exactly 5.
Is it
You know what the exact answer is?
Log base 2.
It's
Log base to Brian did. Log base 2 of 5.
I just broke mine.
Oh my god.
He is correct. This is an exact answer.
That's so.
Why does this have to
How
tie
do you find the
together like
base
that?
too, like on the
Brian,
Okay,
smart
Yeah.
fellow.
You know what? That's another good question. Until we updated the operating systems at the end of last year, it wasn't possible to put a different base other than base 10 and base E on your calculator. It is possible now. I'm not going to waste time showing you. It's on there now. There's 2 reasons why I'm not going to waste time showing you. Most of the time when I ask for an exact answer, we're going to leave it in log form. And there's 2 forms you're allowed to leave it in. This is one of them, and I'll show another one today.
Sorry.
It's under math.
Yeah, I found it.
Yeah, it is.
Yeah.
Okay. So,
You go to math and then it's
Yeah.
Solver.
okay, everybody go to math. Arrow
Yeah.
down a really long way.
2.319280095.
It's
I got
at
this,
number
Rosie.
10. 11.
All right.
11.
Now, so
No, it's not.
Do you math?
I wasn't gonna tell
in
you.
terms of most all the problems we'll do in here,
I didn't say where it was.
we never deal with approximate until the very end. We always live in the exact world until the very end. Okay? So, this, on any other calculator, other than the graphing ones you're holding, you can't do. Like Ryan can't do it.
Yeah, this one.
Because it's not on there.
This one's down.
When you take a standardized test, especially if it's online, you won't have the ability to change the base. So what do?
We get our graphing calculator.
This is what we do.
Whip out that recipe.
Now, if I'm solving an equation, is it fair if I perform the exact same operation on both sides of the equation?
Yeah.
Yes. So is it fair that I introduce this if I introduce it to both sides?
Yeah.
Yeah.
So.
Yes. Now, what can I do with this x?
You can put it x log base natural. No, the log of 10.
So you
Base
can
10.
just divide it by 5.
And then to solve for x, what do I do?
Divided by 5.
No,
divided
what's
by
with
log
x?
of 2.
Log of 2.
And then that goes
What's that?
5.
So this is another exact answer. This is exact. Now, almost all calculators have a log base 10 button though.
Okay.
Whether yours has a log base 10, graphing or non-graphing.
Oh yeah.
I
Any
see it.
calculator that has more than 4 functions will have a log button on it. So you can do log base 10 of 5 divided by log base 10 of 2. Now, obviously, we wouldn't say base 10 because that's a common base, and we just say log of 5 divided by log of 2, and we get approximately 2.322. Yes.
Okay, why do you automatically go to log base 10?
Well,
Natural.
I have two choices. I could have chosen log base 10, or what's the other function?
Log base 8.
Natural log. So let's say I did the same problem, but I took the natural log of both sides. Let's prove it to ourselves. Please do the natural log of 5 divided by the natural log of 2.
Just did it.
Do you get the same answer?
Same exact one.
Yes. So here are 3 acceptable exact answers.
I did not get that.
Figure out how to change it.
Okay.
Did you put the parentheses at the
So
end?
these are our exact answers. This one, and this one. This is our approximate answer.
Oh, you can't add base on this thing.
Yeah, you can. I just figured it out.
Okay, cool.
You have to
There's like a
press it 3
third total
times.
button.
You have to press it 3 times.
I just
'Kay.
figured that out like
That's great.
a minute
Yeah,
ago.
Awesome. All right. So the TI-30, the black calculators will do it. The white ones will not.
We'll be able to use these.
The white ones
I
will
already
not.
had the answer, Em.
Okay.
Why can't you just cancel the logs and log? Like, I don't understand why you just can't.
Then it'd be 2 times 5.
Because it's like the
Because
same.
that wouldn't be the same answer.
Do you get what I'm saying? Why can't you just like
Because
multiply
like,
log out and cancel log out?
because it'd be
It
like
would just be doing
2 times 5 and
Okay.
2 times 16. You can't just simplify whatever number they're divided by out of. You know what I'm saying?
So I can just cancel those out.
Yeah.
No.
Okay. What does this mean?
It's like
The answer to this is an exponent. This is all one thing.
right.
Okay. Then how can you just?
It's
add
not
It?
log base 2 times 8.
But then how can you just add it in?
This is 3 and this is 2. We can't just cancel. That's not a 2.
Okay, so you can add it in, but you can't take it out.
What?
You can't divide it out. You can't divide out the word log.
I mean, like if you add it into both sides and it's equal, I'm saying like you can't just take it out.
That's like if I had 2 to the x and you'd say, okay, just divide by x. That makes that x go away.
No, but I mean it's like on the same level. Okay, never mind.
Because a logarithm is an exponent.
Okay.
So this doesn't work. That won't
You can put
cancel.
them into equation on both sides, but you can't just like remove it once you set it. Does that make sense? Like
You can't
add
just
it in.
No.
Okay.
Because once you add it in, it becomes part of it.
Okay.
I see what you're saying now. All right, so we already knew how to do problems like this, right? Okay, we can do it the same way. If we did log of 4 to the x, log of 8, so this is x times log of 4 equals log of 8, divide by log of 4.
Is log of 4 over log 8? Or log 8?
Okay, now, we can prove without a calculator that these are the same. Because 8 can be written as
2
to the third.
And then 2.
4 can be written as 2 squared. So the 3 comes out in front.
Forget what 2.
The 2 comes out in front.
No, wait.
And what happens to the log of 2's?
They cancel out.
Because they are exact. Log of 2 and log of 2. So did we get the same thing?
Yes.
Yes.
Yeah.
Yes, Mateus.
So will every problem like that be able to be proven though?
Because you're raising.
Not. I gave a simple problem that worked both ways.
You're also
You cannot write this as the same base. That's why we have that other method. Because not all problems can be written with the same base. That's why we needed logarithms. Because there are a lot of equations we couldn't solve. All right. Now, where we take the log of both sides, we end up developing the change of base formula. I don't even like this because you're memorizing something. If we just take the log of both sides and solve, it makes so much more sense. But the change of base formula says I can change from one base to another. And I did. I rewrote it from base 2 into what's the base here? 10. I rewrote it from base 2 to what's the base here?
Natural base.
E. Okay? So I did. I switched bases. But this is the formula for that. You end up doing log of the answer part divided by log of the base. Do not memorize that.
Okay, so you should not write it down.
I will not memorize it.
There's-
Is it log base B?
Because we live for understanding. Memorizing this formula
Doesn't help.
takes us right around the whole understanding loop and takes us straight into memorizing,
I'm a big fan.
which is not understanding.
Well, if I memorize
Team
it,
Pierce.
I can still write it.
Yeah, but then if you memorize it and Miss Willoughby gives you a
What?
weird question on the test, you're not gonna get it.
Yeah.
Good job, Joel. I'll clap for you, buddy. I clap for
between
you.
two words.
Thank you.
But my hands are tied up.
They don't want to get
My hands
both
tied up.
wrong, so I guess it's the same round.
Okay. I've got 2 examples I have to get through before class is over, and I don't do this often, but I'm not going to let you stop me. Okay? So, y'all just, if you need to watch the video later, that's fine. If you need to come in and ask questions, that's fine. But for the people in this class that are following along, we have to keep grooving. Alright, so this problem right here, we don't know what power to raise 7 to get
Log
20.
base
So
7.
we either do log of both sides, or we do natural log of both sides. Now, when you get to calculus and you have either Mr. Campbell or you have Miss Willis, they're going to do natural log every time because it's one less letter.
Wow.
Okay.
Okay? So they're just going to choose ln, and choosing natural log is helpful because sometimes you have a base e in there, and if you end up with ln of e, what is that? 1. So they will always stick with natural log, and I probably will too.
Sweet.
So I'll just use natural log instead of log, common log, because that's what we'll be used to. This is the exact answer. This is what I'll be looking for on the test.
I like that.
Okay.
Okay? Now we can find the approximate answer. Punch it in. What is ln? Natural log of 20 divided by natural log of 7.
1.539.
Okay? 1.539 something where it would round.
1.5395.
Okay. Exact, approximate. You're not getting any credit on your test or quiz on Wednesday if I can't see exact first. If I don't see this first, you don't get credit for that.
Supposed to be on the calculator part of the quiz.
All right, no questions. All right, here's my next problem. A population of a city, starting off with 143,000 people. We are decreasing at a rate of 4% per year. When will the population hit 100,000? Before, all we did on our calculator was shift it down, minus 100, and look at the 0. How do we do it now? We set it equal to 100. And we can solve it algebraically now. Now, to solve it algebraically, it has to be an exponential form first. So anything extra has to go. What is extra?
143.
143. So we're going to divide it out. Do not change it to a decimal. Then you went from equals to approximate. Do not. Leave it.
So leave it as a fraction.
Yes.
No questions.
All right. Now we can take the log or natural log of both sides. And when we do, that t comes out in front. And to solve, all we do is divide by natural log of 0.96. Please punch it in. You must punch every time I tell you to. Because if you don't know how to use your calculator, but you know how to do all the math, it'd be stinky to get this close and get it not 100% right. Okay, so once I punch it in, I'm now approximating. So how many years will it take the population to decline? 8.762.
Is there like
Caroline, did you get it wrong?
Oh, I see it.
Nailed it.
I got it right here.
Same here, dude.
Did you put this in parentheses, Caroline?
Yes, ma'am.
Did you put it at 0.96?
Okay,
I'm gonna try it again. You can keep going.
now here's the coolest problem. This is actually a problem on page 301 in your textbook. I had it open to that page before the book fell off the cart, but thank you, Ryan, for picking that up for me. I'm going to read the problem to you real quickly. It says a paleontologist uncovers a fossil of a saber-toothed cat in California. He analyzes the fossil and concludes that the specimen contains 15% of its original carbon-14. Carbon-14 has a half-life of 5,730 years. Use the carbon-14 dating to determine the age of the fossil. They give us this formula. Okay, so we're trying to find, first, we're trying to find K, which represents our decay rate. Okay, T represents, obviously, time. This represents the initial amount. And this represents the amount remaining. Do all those things make sense? Okay, so from the information in this paragraph, they didn't tell us how much we started with. But can we assume we started with 100%?
Yeah.
Yeah. Well, what number represents 100%?
0.1.
1.
Or just one.
1. Okay, so we're doing half-life. So if we started off with 100%, what's half of that? A half. 0.5. Either way. We don't know the decay rate. But we know we get to a half 5,730 years later. Oops. Okay, so we get rid of the extra, divide by 1. That does nothing. Now, obviously in this case, I would never use log. I'm definitely going to use natural log because I see an E. And I know that makes my life easier. So I do ln of 0.5, that's 1/2, equals, I know this comes out in front, becomes a multiplier, times ln of E. But what is the value of ln of E? 1. So all I have to do to find K is divide.
Oh, I like that.
But when I divide, I go from exact to approximate.
Which is bad.
Matt, do we want to approximate?
Yeah.
No. Never until the end. At the
You
end.
want to get the exact.
Because if we're off by a little, sometimes it doesn't matter. But if we're talking about being off by a little in terms of thousands of years,
a lot.
that's a lot. Or if we're talking about being off by a little in terms of thousands of miles,
That's a lot.
A lot of miles.
yeah.
Try right back.
Our little robot that we send to Mars may not hit it. So we don't want to approximate just yet. Let's finish. So now let's address the rest of the problem. When will there be 15% of the original? So now what number goes here?
0.15.
0.15. And now we know K. Well, this is negative K, and this is negative, so when I plug it in, it becomes positive, doesn't it? T. Okay, divide by 1. Changes nothing. Take the natural log of both sides. This comes out in front, ln of 0.5, divided by 5,730, times T, and times the ln of E.
Oh, you do ln
one.
both times? Oh, because
Which is 1.
Okay.
Okay, so what we're going to have to do is this divided by that. So natural log of 0.15 divided by a fraction. On my calculator, to divide by a fraction, I better put it in parentheses. This is the exact time. But now I'm answering the question. So finally, I can approximate. Please enter that into your calculator and let's see approximately how many years old this little saber-toothed cat is.
So that top part in parentheses.
15?
15,682.8.
I got that.
I'm gonna have to start it over.
Good job, man.
That's correct.
Yeah,
That is correct.
Well, if Matt got it, I mean, he knows it's right.
Dang!
That is not kind.
Joel, I'm disappointed. I still love you.
Okay. So you have some simple homework problems and you have some thinker homework problems. I'll tell you what's not acceptable on the thinker ones. No question marks, no IDKs, no baloney scribbles. None of that is acceptable. Okay? You have an excellent example here to go back and look at. Even if you didn't write it down, it's uploaded to my website.
It is?
Okay? Every day my notes are uploaded to my website. For the past 2 years. Yep.
The answers?
The notes that we do in class every day. Okay, so I'm going to stop recording, Jake, because we're done. Your homework is what it says on the calendar.
Bye, Jake. Bye, Jake.
Everybody cares for you, Jake. Goodbye.
Hey, can we ask questions now?